Anuruddha Kempitiya again. Today we will talk about some more examples on this concept. Uh, Today we are going to talk about stoichiometry of a compound. And what is the stoichiometry of the compound? That is the quantitative relationship indicated by the chemical formula. Right, we will talk about that. Before that, we will we'll have a small recap of the concept. Right, if you take one water molecule, single water molecule, that is the single particle, the mass of single particle can be given as 18U, that is atomic mass unit, or you can say relative molecular mass is 18 just without unit. And also there are some other particles in water molecules, oxygen atom and hydrogen atom. If you take single hydrogen atom, its mass will be 1U, or relative atomic mass is 1. Right. Then I'm going to take 18 grams of water. That is a macroscopic quantity we can measure in our lab. That will contain 6.022 times 10 to the power 23 water molecules. And that quantity of water in the beaker, we can call it 1 mole of water. Okay, and the mass of water in the beaker is 18 gram. And therefore we can say molar mass of water is 18 grams a mole. And also we discuss some mathematical relationships. If you want to find out number of water molecules, how many water molecules? So what you had to do, you had to multiply number of moles of water by Avogadro number. Then if you have 1 mole of water, there will be 6.022 times 10 to the power 23 water molecule. If you have 2 moles of water, there will be 6.022 times 10 to the power 23 times 2. Right. Then again, if you want to find the number of moles, you can use this equation, mass divided by molar mass. Right. Stoichiometry of a compound. Okay, H2O is the molecular formula. Then what is the information inside this molecular formula? It says, if you take single water molecule, there will be 2 hydrogen atom and 1 oxygen atom. Also, we can extend this relationship for macroscopic quantities. Yeah, this is the thing. I'm going to take 1 mole of water, that is considerable quantity of water. If you take 1 mole of water, same relationship. 1 molecule contain 2 hydrogen atoms. Similarly, 1 mole of H2O contain 2 moles of hydrogen atoms. And also 1 mole of H2O molecules mean 18 grams of water. 18 grams of water will contain 2 grams of hydrogen atom. Why? 1 hydrogen atom has the mass of 1U. Therefore, 1 mole of hydrogen atom mean 1 gram. Then 2 mole of hydrogen atoms mean 2 grams. So this is the quantitative relationship indicated by this molecular formula. Now we are going to use this relationship in calculation. Right. This problem number 1. Okay, this problem, you are going to find mass of hydrogen in 90 grams of water. If you take 90 grams of water, what is the mass of hydrogen in that 90 gram? So that is the problem. So this is how we use this relationship. Okay, this is the relationship we are going to use, the mass ratio. If you take 18 grams of water, there will be 2 grams of hydrogen. Then 18 grams is to 2 grams. Now I am going to convert it into my quantity. My quantity is 90 grams of water. So I'm going to divide both sides by 2 and then multiply both sides by 10. Then I am getting 10 grams of hydrogen atoms. So answer is 10 grams. 90 grams of water contain 10 grams of hydrogen atoms. We will use mathematical equation for the same calculation. These two mathematical equations going to be used for that purpose. Right. Here, first I'm going to find the number of moles of hydrogen atoms. First, number of moles of water, that is 5 moles. Mass over molar mass. Then we are going for the stoichiometric relationship. 1 mole of water molecule contain 2 moles of hydrogen atoms. Number of moles of water is to number of moles of hydrogen, 1 is to 2. Then 5 moles is to 10 moles. The number of moles of hydrogen atoms is 10 mole. Then we are going to convert it into mass. Using this equation, mass of hydrogen atom equal number of moles times molar mass. So 10 moles times 1 grams a mole. 1 grams a mole is the molar mass of hydrogen. Now we are getting 10 grams again. In the second problem, they have given you the quantity 100 grams of water. So they are asking you to find how many moles of hydrogen atoms in that 100 grams of water. That is the problem, right? This is the relationship we are going to use. This time we are going to use a cross relationship. And mass of water is to number of moles of hydrogen atom. If we take 18 grams of water, there will be 2 moles of hydrogen atom. That is the relationship. So 18 grams of water, 2 moles of hydrogen atoms. Then what we are going to do, we are going to convert this 18 grams into 100. So you divide both sides by 18, multiply by 100. So you are getting this answer, this relationship. 100 grams of water, 2 into 100 over 18. Then number of moles of hydrogen atom will be this, 11.1 moles of hydrogen atoms. Same calculation from the equations. This time we are going to find number of moles of, always we are going to find number of moles of water available. Right, that is 5.56 moles, because number of moles equal mass over molar mass, 100 grams over 18 grams a mole. Then we always use molar-molar relationship. That is 1 mole of water contains 2 moles of hydrogen atoms. Therefore, 5.56 moles of water will contain 11.11 moles of hydrogen atoms. Then therefore, the answer is number of moles of hydrogen atom in 100 grams of water is 11.1 mole. This time the problem is slightly different. You are given some number of hydrogen atoms. In a certain water sample, there are some number of hydrogen atoms. They say 36.12132 times 10 to the power 24. That's a large number of hydrogen atoms. So they are asking, what is the mass of water that contain this number of hydrogen atom? This is the problem, right? Okay, first of all, we have to convert the number of atoms into number of moles of atom. So we are going to use this equation, the relationship number of particle equal number of moles into Avogadro constant. So number of moles going to be number of particles over Avogadro constant. Number of moles of hydrogen atom equal number of hydrogen atoms, number of particles over Avogadro constant. So number of hydrogen atoms, this large number, divided by the Avogadro number. So Avogadro number has the unit per mole. So you are getting, the simplification gives you 60 moles. 60 moles of hydrogen atoms available in the considered water sample. Right, now we are going to find out what is the mass of water sample that contain this number of moles of hydrogen atoms. Right, this is the relationship. Number of moles of hydrogen atom is to mass of water. This is, see, 2 moles of hydrogen atom, 18 grams of water. Only 2 moles of hydrogen atoms in 18 grams of water. So we are going to write that relationship. 2 moles, 18 grams of water. Then 60 moles, so you have to divide it by 2 and multiply by 60. Then 60 mole, 18 grams into 60 over 2, that is the mass of water. So when you simplify that, you are getting 540 grams of water. That means 540 grams of water contain 36.132 times 10 to the power 24 atoms, hydrogen atoms. We are going to solve the same problem using equations only, right? Similarly, you have to find out the number of moles of hydrogen atoms from the number of particles of hydrogen, that is 60, similar to the previous calculation. Then this is the molar-molar relationship. 2 moles of hydrogen atom will be in 1 mole of water. So 2 moles is to 1 mole, that is the mole ratio. Then 60 moles is to 30 moles. So we get 30 moles of water. Then we can convert that moles into mass using this equation. Mass equal number of moles times molar mass. Then number of moles 30 times 18 grams a mole. Again you are getting 540 grams of water. So the meaning is there will be 36.132 times 10 to the power 24 hydrogen atoms in 540 grams of water.